Text is the second visual cue and plays a huge role in providing the key clues our viewers use to understand our visualization. In short, it helps you in making sure that your visualization is killer and not filler. Here's a table showing what kind of context text can provide. Titles summarize the subject of your visualization. Labels clarify data within the chart. Annotations explain trends in the data, and legends map visual cues to variables. We saw this already when we were creating our scatter plot, and we had that little box off to the side telling us what each color meant for each biome. We'll go over this again when we do our next actual live demo. However, text is useless if you can't read it. Keep it legible, large enough to read, and in a color that doesn't hurt people's eyes. Reading text off of your visualization should never have to be a chore. Now, I personally have a preferred font for when I'm creating my own visualizations, and if you're thinking that it's Times New Roman or Arial, you're wrong, because scientifically the only good font is Wingdings. Why don't we get to developing our visualization further with the new visual cues that we just picked up? So, first things first, let's go ahead and add ourselves a nice title to fit what we're trying to show the user. So this is mean annual precipitation versus mean annual temperature. And then we'll hit OK. There you go, we have a nice new title. The legend that we talked about, once again, showing what each biome is for each color, is up here. This is a legend. Show me, by the way, is up here, and you can see that it's suggesting a bunch of different options. We brought this up earlier in the presentation. Just wanted to make sure that you know where it was. And let's get to actually adding some trend lines to figure out which points are lower than are expected. So let's right-click, go to Trend Lines, and click on Show Trend Lines. Once again, that's right-click, go to Trend Lines, and Show Trend Lines. And we're greeted with this mess. Now what's happening is that Tableau is providing us a trend line for every single biome. Now this isn't actually helpful when we want to try and figure out what points are low compared to the entire world, and for that temperature for the entire world. So all we have to do to fix this is go to a single line, right-click, click on Edit Trend Lines, go to Options, and then under the options you'll see Biome. You can just unclick and click OK. So there you go, we have a single trend line for the entire world. In this case, we can see that these points that we were talking about before with very little rainfall are definitely far below our actual trend line. So we now need to figure out where they are on the world, because this is probably a place that we want to be selling our product. So to do this, all we have to do is make sure that we add labels to each individual point. We should go over here to country, because we're looking for where in the world they are, and we can drag these down onto labels. And there you go. Now we have a label for a lot of locations of the world. Now, you may see that some of these points don't actually have their labels visual immediately on the cue. So for example, these points over here by the trend line. And maybe you don't have all the same labels as I do. Let's say perhaps maybe this label for you over here doesn't have, or this point doesn't have a label. These things change depending on your screen resolution in Tableau. So if it's not working for you entirely in the same way that I have it, then don't panic. Well, let's go down over here, because now we can see that we have these two very, very low points, and this point as well in the US, which is a very big country, so we should narrow it down. Israel's in the middle of a desert, so I'm expecting that to look very low. But the US, well, it's surrounded by water. Let's try and figure out where these places are. But before we do that, let's jump back into the presentation and introduce a couple more ideas before we do so. You can now see why scatter plots are so great for identifying outliers in a dataset. But for now, that's all they're really good for, identifying outliers. They don't explain to us much about why they're actually outliers. For this, we're going to be turning to the information that we just put on as a label, the geographic information. This is called harnessing a point's spatial data. Now, spatial data is just information telling us where something is on a map. Longitude and latitude are some of the most well-known examples of this, but country, city, province, anything following that sort of idea also count. During data collection, you may come across other types of coordinate systems other than longitude and latitude. Out of my own experience, I recommend avoiding them as they can get complicated fast. Keep in mind that spatial data isn't very intuitive. Unless you've worked with a coordinate system many times before, latitude 11.9, longitude 50.1 isn't going to mean much. Due to this, mistakes in data entry from your source can easily slip by unless you're very careful. For example, when preparing the dataset for this workshop, we ended up finding a few points off of the Somali coast, you can see a picture right over here, that were massive outliers for the region. Upon closer inspection, we found that they were labeled Germany, and their latitude and longitude were actually swapped by accident. Moral of the story is always check your spatial data. Now, by putting these points down on a map, we can look at geographical features like nearby coastlines, mountains, deserts, etc., so that we can get better context for why those points are there. We're now uncovering the reason for why these points are outliers in the first place. We're going to get familiar with this idea by first constructing a very basic heat map. Now, it won't exactly show us anything that we don't already know, but it will give us a good idea and highlight some key topics that I'm going to bring up a little bit later. So let's open up Tableau, and we're going to start off by creating a new sheet. I'm going to rename this sheet heat map by double-clicking on it. I can also rename this over here and call this scatter plot, just for keeping track of everything. And the first thing that we're going to do is go over here to country and drag this down into the middle. There you go. Now we have a point showing every single country that we have information/data for. And to create a temperature heat map, all we have to do is go down here to mean annual temperature and drag it over here to color. There you go. Now, first things first, we remember that everything starts off as sum, so we're going to change that from a sum to an average. And just like before when we were dealing with our spreadsheet heat map, we're going to go over here and reverse the colors so that blue is cold and red is hot. So let's edit our colors. Click on reverse to change the scale to be the opposite direction. And to make sure that we have an idea of what countries are cold and hot in relation to one another, as opposed to comparing it to the absolute point of freezing water, we're going to change the center from 0 degrees to 10 degrees. You can calculate this yourself. It's about the center of the scale. Okay, so that's cool. We now have, if I quickly switch over to the pan tool, you can now see that for all the countries, we have an idea of what their actual average temperature is for every year. The reason why we decided to revisit this idea of solely looking at temperature is if we look over here at the United States, where we originally identified in our scatter plot to being the points that are so very low and away from our trend line, going back to the heat map, we see that the United States is a really big place. And the same applies for a country like Russia. But while Russia expands over a similar heat and temperature area, a lot of it being up very north, the United States acts a little bit differently. You can see that the US tends to be a little bit hotter, but that includes Alaska. Therefore, we are diluting our information across a very wide area, and we're missing a lot of the finer details of our data set because we're just abstracting a level. We're taking a step back and covering everything with a blindfold rather than looking at things with a fine-tooth comb. So, because of this, we're going to have to take it a step down lower and go from, say, just countries looking at. We're also going to go ahead and look at region. Now, region for the United States and for Brazil and for certain other countries in our data set includes states, provinces, territories, etc. To get a better idea of what we're dealing with, especially in the United States, because the United States is so big, we're going to want to take a look at where exactly these points in the US are. First thing to do is we're going to create a copy of this scatter plot. We're going to right-click, and on the scatter plot sheet, we're going to right-click and go to duplicate. So we now have scatter plot 2. We're going to call this one US scatter plot. And I'm going to change the title up here as well. And so that I only exclusively see points from the United States, because we've decided that's where we're going to be looking because of these very low-lying points from the trend line, I'm going to apply a filter. Now, a filter is a very simple tool that lets us look at a very specific slice of information. So I'm going to go ahead, pick up country from our dimensions tab, and drop it into filters. Next, I'm going to go all the way down to the United States, uncheck that, and then change the box so that all the checked boxes don't include them, but rather exclude them. So you can now see that I've excluded them. All the checked boxes have been crossed out, and we're only looking at the United States, not the United Kingdom. My bad. Okay, so let's apply. And okay. So now these are all the points that we found that are in the United States. But because our text label is country, and we already know that everything is from the United States, this is kind of pointless. So we can go ahead and drag this off. What we're interested in is finding out where within the country each of these points actually are. So let's go ahead over here, and instead of putting country as the label, we're going to go ahead and put region as the label. We're going to drop this off. And there you go, now we have it. We can see that this point, this especially low point, is California, and here is Nevada. Now, Nevada is in the middle of the desert. We can expect it, even though it's a little bit strange to be so far away from the point, we can kind of understand why it's in the middle, why it's so low and receiving so little rain, because it is in the middle of a desert. California, however, is on a coast. It's surrounded by water, in a sense, on its most western edge. So this is interesting for us, and I feel like this would be a good direction to actually push forward and take a look more deeply in California. So let's quickly jump back to the presentation, and instead of visualizing spatial data by country, we're going to go ahead now and, with another live demo, boost our visualization with extra spatial precision using regions as opposed to countries. We're now getting a better feel for our data set. Remember, it's important to utilize every single piece of information you have at your disposal. If you don't, you may be glossing over some very important points that would totally change your end decision for where we should put our crop. So why don't we go ahead and start boosting our spatial precision? First thing that we're going to do is we're going to create a new sheet. And this time, instead of dragging and dropping country, we want to get a little bit more specific. Luckily, we have the latitude and longitude of where these measurements were taken. We're going to go ahead and drag these into the columns and rows section and change these from averages to dimensions. These are on a set of axes right now, but we want to make sure that we're putting them on an actual map. Let's go ahead and do that by clicking on Show Me, and then going over here to the symbol map. There you go. Everything's plotted. Now, what should we do next? I have a feeling that we should start off by putting our temperature back, because we want to look at how temperature affects precipitation. And if there's a high temperature and an unexpected amount of rain, or too little rain, then we know that we may be experiencing a drought somewhere. So let's go ahead by first taking our mean annual temperature, dropping it into color, changing it from a sum to an average, going back to this little arrow next to our color key, edit our colors, reverse to change blue to cold and red to hot. We've already done this, so I'm glossing over the steps. Change the center to 10 degrees. And now we have a good idea where everything sits in relation to one another. This is starting to make a lot of sense, since our hot points are down south in, say, Texas and Florida, and our cold points within the United States are up in Alaska. We're now getting a better feel for how this information plays out, and it's a lot more realistic. I'm going to make one more small change for my own personal preference. If you click on this button over here, Colors, we can actually give everything a black border, which I feel makes it stand out a lot more. Okay, now we want to take a look at how rain plays into this situation. How does precipitation actually fall in these areas, and do we come up with points that seem too small or too large for where they should be? So Let's go over here to mean annual precipitation. Drop this into a new visual cue, size, and we see everything starts to change. We're going to change this from a sum to an average. And I personally like to go over here. There's this button over here under the key. Click on Edit Sizes. I like to make it a little bit larger just so it's easier to see. There you go. Maybe a little bit smaller. This is something that you can play around with yourself. Okay, so now that we have all these points built up by size, we see that there's a lot of stuff overlapping, and this can obscure data, and it's generally a problem. So what I like to do to remedy this is that we can play with another visual cue. We're getting two this time. We can go over to color, and over here we see opacity. Now, opacity just means if you can see underneath a point or not. And when we have a lot of points clumped up together, it's really useful to make everything very, very see-through and transparent. Because when we do that, we can actually see what points are overlapping each other. And if we zoom in over here, we can actually now see that there are many points in this one area, many measurements, that we wouldn't have been able to see if it wasn't transparent. So we can off-click of color again, and we can go ahead and zoom in. And remember, we're focusing on the United States. But before we do, I want to point out, you can see that these points are massive for where they are. And when we zoom in, we see that this is actually Hawaii, and see how much rainfall that they're actually getting. When we look back at the US scatter plot, we see that these guys are also outliers, just in the opposite direction. And now that we see it on a map, we can comfortably conclude that this massive amount of rainfall is probably due to the fact that it's surrounded by water. It's an island. Same thing if we go ahead and I scroll over using the pan tool, scroll over to Puerto Rico. It's an island. Costa Rica. It's very thin and surrounded by water. Of course, you're going to get a lot of rain. But let's go ahead and focus in on California, because while we see a fairly consistent amount of rain all across this area, once we get closer to California, we see that the points are actually getting a little bit smaller, even though they're on the coast. So zooming in, we can see that there's very, very, very tiny point right over here. And you can see that these points are relatively small in comparison to everything. Now, to me, this is really starting to have me feel like this is a place where we would be experiencing droughts. This is a place that we want to actually sell our crop. There's one thing that I do want to point out, though, is while all these places are fairly hot, we can see that this one place over here, this point of measurement, is actually quite cold according to with relation to everything else. You can pause the video right now just to take some time and think of why this might be the case. Alright, if you guess that it's because it's on top of a mountain, you can actually see over here that there is this darker spot. You would be correct. And because it's on top of a mountain and it's so high up, the ambient temperature around the equipment detecting the heat of the day would actually be much colder. Same thing. Maybe it wasn't taken during the day. Maybe it was taken at night. That's also a reason for why it may be colder. These are things that you wouldn't be able to tell unless you took the time to place this down on a map and look at the specific geographical information behind it. Alright, I'm feeling pretty good about our decision to take California. Why don't we jump back into our presentation and take some time to do some last-second verification before we make our final decision. For example, what is the most common type of soil in California? It would make sense if we tailor our crop to best suit the environment we plant it in, so it thrives and has maximum market impact. To figure this out, we can use a count. Counts are just the number of times a certain value appears in a dataset. If we want to find out the most common type of soil in California, we should count the number of times each soil appears in our datasets within California and rank them based on that. Obviously, we're limited by our dataset here. If you have a relatively incomplete dataset from a single location, the observation we make from a count will probably not be very useful. To visualize this, we will make use of a new visual cue, the angle. Pie charts are the most recognizable form of the angle visual cue. Let's create one right now to compare different soil types in California. We're going to start off by creating a new worksheet. And within this worksheet, I'm going to go up here to soil type and drag it twice, once into columns and once into rows. Because we want to take a look at the count of each soil type, we're going to go to one of these, click down, and turn this into a measurement and that measurement into a count. We now have a nice bar chart, but since we're looking for a pie chart, all we have to do is click on Show Me, go down to this pie chart button over here and click on it, and it'll automatically happen for us. Now, this looks a little crazy, and it highlights some real importances about the color and angle visual cue. Where do they fail as a useful visual cue? I'm going to start off by dragging this out a little bit. This is a tiny bit difficult because there are invisible margins that you have to find. Eventually you'll get used to it. And asking you a question directly, can you tell me the difference between this pink and this pink? Probably not easily. We want this to be an easy distinction, and in this case it's absolutely not. This happens mostly because as soon as you get around above 10 different color categories, it becomes incredibly difficult to actually easily look at the color cue, which is over here, the key for colors, and then link that back to one of these colors over here. If I didn't have any labels, like I don't right now, then could you look over here and tell me where clay terra rosa appears on this circle? Probably not. Something else, when we're looking at angles, some of these angles are so tiny and small in the differences between them that you can't really tell the specific differences between one angle slice and another. For example, could you tell me exactly how much the difference is between this slice and that slice? If I hover over it, yes, but it's quite difficult to do. And this is because the human brain has a hard time recognizing angle differences between something like maybe 1 or 2 degrees. As soon as you get up to something higher like 5 degrees or maybe 10 degrees, then it makes a real difference. But at 1 or 2 or 3 degrees, it's fairly difficult. We only want to look at soils in California, and these are the soils from the entire planet. So, why don't we apply a filter and see how that cuts down on the number of soils in our color cue. Let's go over here to Regions, drop it into Filters, and then select California. Nice. So, right now we have a very nice and distinct pie chart with different colors and very clean angles and not too many things happening on this pie chart at once. You may have a different color set, that's okay. Over here, underneath the color key, or cue, you can go over here to the drop down arrow, click on that, and click on Edit Colors. There are many different color types that you can use in Tableau. If I go to the automatic and click Assign Palette, and click Apply, you can see that we have a very, in my opinion, much more dull color set. It's a lot less interesting. I personally prefer the hue circle colors because they are very distinct from one another and they don't overlap very easily. Once you get a lot of them, that becomes the case, but until that point, it becomes really nice and distinct from one another. I'm going to click OK. I'm going to go personally, I like my borders, so I'm going to add a border. And lastly, we need to add our labels so it's easy to distinguish what is what. Let's go over here to find our soil types. We're going to add a label for soil types. Then we're going to go over here to this angle visual cue over here, and we're going to drag it onto our label. We now get a nice count underneath of how many of each soil has been measured for each entry in the pie chart. But I'm more interested in overall percentages because at a glance with a percentage you can get a quick reaction and understanding of what's going on. So to do this, I'm going to go over here to the count, click on the drop down button, go to Quick Table Calculation, and click on Percent of Total. There you go. now I have a very quick and easy understanding of where everything sits on this pie chart. I'm going to go over here and change my title to Soil Types in California, and click that OK. And I'm going to rename my sheet to be Pie Chart. So there you go, a very nice and distinct and easy to read pie chart. In this case, you'll also see, once again, screen resolution in Python and Tableau will actually sometimes cut off certain labels. So if you don't see everything to be exactly like mine, that's okay. That just means that your screen resolution is probably a little bit lower than mine. So, back to the visualization workshop, and let's see what else we can do to help finalize our decision. However, before pushing any more forward, there is something incredibly important that I shouldn't mention. Scales, while not incredibly exciting at first glance, can make a massive difference in your visualizations. Think of this example. I, as an investor, decide to buy a beachfront property. The person selling me the land shows me the graph on the left. They'd probably say something like, wow, look at this massive property value increase. You'd have to be crazy not to buy. If you pay close attention, though, the scale starts at 940,000, not zero like one would expect. The visualization becomes biased, and the increase in price looks huge. The viewer is tricked into believing something that isn't true, because once you set the scale to start at 0, you see the truth. There was hardly any change. Biased visualizations are dangerous for the same reason that fake data is dangerous. It can lead you to make decisions that hurt you much more than help you. This tactic is very common among commercial and political ads, so I recommend you keep an eye out for them in everyday life. I guarantee that sooner or later you'll find a visualization biasing itself with some sort of inconsistent scale. The last type of visualization I'm going to introduce you to is the time series graph. Simply put, it shows how a variable changes over time and what patterns emerge from it. Interestingly, you can change what patterns a viewer focuses on based on how you present the points of your time series. Want to focus on individual points? Draw a scatter plot. Want to focus on the change between 2 points? Connect each line to the one that's next to it, and you'll form what is called a line graph. Want to focus on the overall pattern for your variable over time? Draw a trend line like we showed you earlier in the video. Let's set up a time series graph to confirm that California is actually at risk for droughts. Alright, first thing that we're going to do is create a new worksheet. From this worksheet, I'm going to go ahead and start investigating whether California is prone to drought activity. So, what I'm going to do is I'm going to take my mean annual precipitation, put that on the y-axis, and I'm going to take my study mid-year and put that on the x-axis. So this is time on the bottom, amount of rain on the y-axis. I'm going to change these both from sums. Study mid-year is actually not a sum, so we want to make it a dimension because a year is a singular thing. And what we're going to do for our precipitation, this is our average precipitation, so we want to change it from a sum to an average. Nice. This is looking a little crazy, but that's because we're looking at the rainfall for the entire world. What we want to do is look solely at California, so that means we need to add a filter. Taking this region filter, dropping it in, and solely selecting California will make it so that our graph is a lot more clear. And all of a sudden we can see some very clear patterns emerge. There are periods of very low amounts of rain, and then high, and then low, and then high, then low. To me, this is starting to seem like there is a consistent drought problem in California. But there is a relationship between amount of water and amount of heat in a given area. So why don't we add a visual cue to start throwing in some information about how hot California was in that year? Maybe we can find out some more information. Let's take our mean annual temperature, drop that in color, change that from a sum to an average, And then from here, I don't really like this color palette. It's a little bit too subtle for my taste. So I'm going to go over here and edit colors, change it from automatic down to red, blue diverging. And then I'm going to swap the colors so that blue is cold and red is hot. And I'm going to apply and click. Okay, so we now have precipitation over time, rainfall over time, and how hot it is being displayed in how dark red it is. Or alternatively, how cold it is being displayed in how dark blue it is. Now this is nice, but I think that we can emphasize that relationship between heat and rainfall even more. How do we do that? Super simple. We can add another visual cue exclusively for mean annual temperature. There's no rule saying that you can only use a single visual cue per item. As a matter of fact, as I said earlier in the workshop, you can add many on top of one to create a highlighting effect. So let's do that. Let's take mean annual temperature again, and this time let's put it under size. Nice. So let's change this from a sum to an average. And now we can see when it's very, very hot, the line will be both thick and dark red. So now we're getting a little bit more information where we can see that it gets very hot and then the rain falls down and it cools off, and then it gets very hot again, and then it starts to cool off. This is an anomaly that I think we want to take a look at later, but I do have one more trick to help boost clarity to our viewer. What we can do is we can take our mean annual temperature and dragging the pill, carefully bring it down to the axis. You'll see two rulers appear on top of each other. It's important that they're on top of each other and not beside each other like this. Otherwise, you're going to get something that we don't want. So, two rulers that are on top of each other, and all of a sudden, we get two separate graphs. Now, we now have these drop-down menus, and from this point on, it's very, very, very important that what we do is we stick with the bottom. So we'll see that this drop-down menu is exclusively for mean annual temperature. Make sure that you're focusing on mean annual temperature and not anything else, otherwise we'll ruin what we just created up top. So let's, once again, in this mean annual temperature drop-down, not the mean annual precipitation, we're going to drag off these pills, and we're going to change it from automatic to a circle. So now we have these singular points showing different points of temperature over time, in addition to showing the thickness and the color. What we can additionally do is take temperature again, put it into a label, then take that label, turn it from a sum to an average, and all of a sudden we have a corresponding point for every single precipitation point showing the temperature. There is one more trick that we can do, which if on this graph you right click and click on drop lines and click on show drop lines, if I highlight them all, you can see them drop down. Now, this isn't very practical because we have to highlight them to do this, and they're also pointing on the side, which is not entirely useful. So what I will do is I'll right click here, go to drop lines again, and edit my drop lines. This time, I'm going to want it to only drop to the x-axis and drop always. Click OK. And all of a sudden, now we have lines dropping all the way down to each of these points from each point on our precipitation graph. Now I feel that our user, or rather our viewer, is getting a very strong idea of the relationship between temperature and the amount of rain in an area. Lastly, we're going to want to add some annotations. We're going to want to help tell and build this story and give an idea of what's going on in certain world events. First things first, let's look over here at this blue dip. This seems odd. And the study year is 2003. Well, if we recall, let's jump back to our heat map 2. There is this one blue point in California. And that's because it's on top of a mountain, probably taken maybe later in the day when it isn't as hot, or just at such a high altitude that the temperatures are colder. Let's jump back to our time series graph. And we want to let our users know what's going on. We want our viewers to understand why that is cold. So what we can do is go to this point, right-click, go to Annotate Point, and we can fill that in for ourselves. So we can type in mountain data. There you go. We now have this text box which we can drag up and leave like this, and now it's pointing right directly to this little thing over here. What about over here? What's going on? Now, we already did a little bit of research, or rather I should say I did a little bit of research before building this graph for you guys, and I already know that this point in time in 1994 is the end of a major drought in California. So, I simply found this by Googling rainfall 1994 California. And all of a sudden we're adding a lot more context to our viewers. We're leaving them with these little hints that they can follow along and say, oh, I understand why they made this decision. I understand what's actually happening in this data. I'm going to change the title of the actual graph to be precipitation over time in California. I'm going to change this O to a capital O. Okay, and there you go. I think that we have something very, very effective and very, very telling for our viewers to actually sink their teeth into and understand why we think that California is a drought-prone location. Okay, we've made all the visualizations we need to convince ourselves and somebody else that California is a really good place to sell our product. You can show each of these visualizations individually, but having them all in one place makes it much easier to read and can really reinforce the idea that everything ties into one final decision, the end point of your story. In Tableau, we can do this via dashboards. So let's go ahead and make ourselves a dashboard right now. To do this, what we have to do is, instead of clicking on New Sheet, we go to New Dashboard, which is right next door. I'm going to quickly change this to, say, Time Series, so that we have an idea of what's going on. And over here at the dashboard, all we have to do is go over here and drag and drop. There you go. We can even go around and zoom out if we wanted to by Control mouse wheel. And how about we go ahead and take our time series, because we thought that was really good. There you go. We now have our time series. Maybe we want to make it a little bit bigger. And everything is very, very pliable in this actual screen. So all you have to do is drag and drop. So maybe I would like to move this a little bit down. So all I have to do is something like this. Same thing goes for this color scale. We can also add, say, our pie chart to the side. And there you go. This itself is a careful balance to make sure that it's actually legible. But you can get a solid idea of how you can create an interactive, easy to read dashboard full of different visualizations by the end of the day. This is an online lecture, so unfortunately there's no Q&A. However, we're pretty much done now. So now it's your turn to solve problems using your own visualizations. Here are some questions. Pick any one of them and use the additional data sets we have provided to find answers for them on Tableau. Feel free to pause here and try them out. Did you enjoy the process of solving a problem using data visualization? Want to try it again, but this time on real-world problems with great prizes going to the best solutions? Take a look at STEM Fellowship's Big Data Challenge. It's a practical application for what we learned today and can help you get a foothold in the fast-growing industry of data science. available at both the high school and university level, follow the on-screen link to find out more. Here are all the credits for everything that we used today. All credit goes to the amazing pieces of artwork and the amazing visualizations that we used earlier in the lecture. And lastly, many thanks for sticking around for the whole lecture. This really is a passion of mine, and I'm thrilled to see that you've taken an interest in it. Until next time, I'm Gabe. This workshop has been provided by STEM Fellowship, and remember, don't be afraid to innovate, explore, and create.